Hi everyone, and welcome back to Fundamentals of Engineering with Farhad. Mechanics of Materials, Moment at the fixed end, M sub B. In this example, we have like a prismatic beam which has a fixed support at A and a sliding support at B, handling a concentrated load of P at as a sliding support at B. We want to calculate the moment created at B. To do so, we can dissect the beam to two cantilever beam, one with the concentrated load, and then removing the a, a sliding support and replace it by a moment and call it like M. Then calculation of theta for B induced from each of this part, like theta B induced by concentrated load of B, and then theta B created by the moment at B will add up together to give us the total moment at B. So theta at B is equal to summation of both of them, and because NB is sliding and the sliding is a kind of fixed, then theta at B is equal to 0. Then the summation of those two, theta at B is equal to theta B from concentrated load plus theta B from the moment created there, and they should be equal to 0. So again, theta at B, because B is in the original form is sliding and that's kind of fixed there, so there is no theta at there. So if we add up them together, so the theta at B for the first cantilever beam due to concentrated load of B is PL squared over 2EI, and then theta at the created with a upward moment or counterclockwise moment is ml over ei, and then we add these two up with each other, and then because the direction is opposite each other we have to subtract them, and it just gives us it's equal to 0. It can easily give us what m at b is. Like the only unknown in this equation is mb, and that's give us a m sub b is equal to half of a pl half of pl, so or pl over 2. That's how we can base off the theta b is equal to 0, and then consistency between the summation of these two in superposition of these two theta, we can easily get the unknown of mb. Thank you. In the next video, by knowing what mb is, we will calculate the delta at b. Thank you.